Okay, so let's solve this problem. So what is the problem statement is, let's say you have a given and positive integer, and you have to complete a function by writing like, if a integer is given, then you have to find out that how many ones are there in that integer's binary. So in this example, you can see here, let's say the n is given 11. So binary, if you calculate the binary of 11 is nothing but 1011. And simply you have to find out how many ones are there. Simply for 128, the binary will be 1 followed by 7 zeros. So you can easily count that how many ones are there. So to solve this problem, basically two things we need to understand. One is the bitwise AND operation, and maybe bitwise right shift. So if you understand these two operators, then I think we can easily solve this problem. So let's see how we can solve it. So before jumping to the solution, let's try to understand how quickly we can understand that how bitwise AND operation works. So for example, if let's say n is equal to given 5, and in 8-bit binary representation of 5 is nothing but 1, 2, 3, 4, 1, and then 101. So what it does is, in 8-bit zeros, and then 101 will be the binary representation. So the logic what it says that, just if you multiply with 1, I mean if you perform the AND operation with 1. So what is the binary representation of 1? Is nothing but again lot of zeros and then 1. So if you perform this AND operation with any number, it returns, you can see here, it returns 1 into 1, I mean 1, and 1 is nothing but 1. And remaining will be 0, because if you perform any AND operation on any number, it will be 0. So output will be 1. It is nothing but just 1. So what analogy is saying is, whatever the last bit is there in that number, if you perform any AND operation with 1, it will give this as a value output. So if you give any number, and if you perform the AND operation with 1, it will always return the last bit of that number in the binary. So what we understood from is that, if you give any number, you can easily calculate what is the last bit of that number, and then you can simply check that that last bit output is 0 or 1. If it is 0, just count it, because you have to find out only set bit. If it is 1, you can simply count it in the set bit. If it is a 0, you can count it as a unset bit or 0 bit. So takes another example quickly. Let's say n is equal to 6. So the value is nothing but 110, and just assume that few zeros are here also. Now if you perform the AND operation with 1, the output will be, you can see here, 0 and then 0, 0. So output is will be nothing but 0. And why this 0? Because the last bit of the 6 is 0. So you can simply just compare that this is a 0 or 1. If it is output last bit is a 0, just count as a in the 0 variable. If it is a 1, then count plus plus into the 1 variable, and easily we can find out. Now there is another is the right shift operator, bitwise operator. So this what it does is, simply if you perform any let's say n is equal to 5, and the value is again 101, just assume that few more 50 will be the left side. And if you perform the right shift operator, and if you do the right shift by 1, this will be nothing but it will deduct the last bit, and simply it vanishes, and then it appends the 0 on the left side. So what will be the output of this n is equal to 5? Right shift 1 is nothing but 1 0. 1 will be vanished, and it appends the 0 in the left bit. So it will be now again. So this 5 is nothing but now 2. So this also we say that if you are performing the right bit means you are dividing a number. If you are performing the left bit means you are multiplying a number. So that is the analogy for right shift and the AND operator. Now using these two things, we can easily find out what is the how many number of zeros and ones are there. So let's jump to the code. So as we have discussed that we can simply find out the zeros and ones. So let's say I am just making that count is equal to 0. So since I have to find out just one, so maybe we can say that if n and 1, so this will give the last bit of the end if equal to 1. So we can count each, right? Count plus plus we can do. And then we can return the count. Return count. Now this is very good for the just last bit. It will count it. Now we have to find out the number of ones for the all nth bit. I mean all n bit of this integer. So we can iterate through the for loop. So let's say if n not equal to 0, since we know that it's a positive number, so the input will be definitely greater than 0. So we have to, let's say n is equal to 5 is coming or n is equal to 11 is coming. So definitely it will be not 0, and then it will check the last bit. Now for each last bit, it will count. So in the next part, what we have to do? We have to do the right shift by 1. So if you perform this right shift by 1, what will happen now? The next time it will divide by 2, and it will give the second last bit. I mean, the second last bit will, we can easily count it using n AND operation, right? So simple thing is that just find out the every last bit and check if it last bit is coming as a 1, just count and just return the count. And if you run this, it should give the output how many ones are there in the n number. So you can see that if n is equal to 11, output is 3 again. So all test cases will be passed. Again, suppose if you want to make it something like, even if you want to count at 0, so simply you can see here, uh, you can compare one more thing, that if n equal to 0, so you can count as 0. This problem we can solve, we can optimize few more things, like we can do here also count is equal to count plus n and operation 1. So what it does, if this gives the 0 and if you are adding to the count, it will not affect anything, right? So, and if it is giving 1, then the count will increase by 1. So this is also as equal to what we are comparing last logic. So this will also give the overall count result. You can optimize little bit more because you are using uh, same variable. So this will also return the same output, right? So this is the main thing, that just take a count variable and just count how many ones you are giving. So this will return ones, and then you are keep adding into the count, and using this operation you are going to the next bit. So I mean here, let's say if n is equal to 6 1 1 0, for example, So first time you counted with AND operation, so you gave the output as a 0, and then you perform the right shift. So right shift means it will give 1 1 and then remaining 0, right? So if you perform again 1, it will give the last bit as a, it was coming as 0, here it will come as a 1. Again if you perform one more right shift, so the value will be now, this will be last bit will be vanished and one more 0 will be appended. So overall it will be like only 1 and then followed all the left side 0. If you perform again 1, so it will give the output as a 1. So 1 times this one time is this one. So the 2 times 1 is there in the 6. That is the output. So this way it will come. That's it. Thanks.